Rosie here. In this question, we're given an equation and we're told it has equal roots, and we're asked to determine the possible values of k. Now this equation has an x squared term, an x term constant that equals 0. It's of a quadratic equation form, ax squared plus bx plus c equals 0. Now we know how to solve equations like this. We use the quadratic formula, where we have minus b plus or minus the square root of b squared minus 4ac all over 2a. There's the plus version of it, the negative, the minus version, minus b squared minus 4ac all over 2a. Now this would imply we have two solutions to that equation, but of course it all hinges on b squared minus 4ac. If this is positive, this discriminant is positive, then we will get plus the square root of a number minus square root of a positive number. We will get two solutions. If it's 0, then adding the square root of 0, subtracting the square root of 0 makes no difference. We'll get one solution. And of course, if b squared minus 4ac is negative, we can't find a real number that's the square root of a negative number. There will be no solutions at all. Let's look at a graph just to try and to understand properly what I've just said. So here's a quadratic graph. A is 1, b is negative 4, c is 3. This is x, the graph of y equals x squared minus 4x plus 3. If we try and solve the equation x squared minus 4x plus 3 equals 0, we get two solutions. X equals 1 and x equals 3. Notice the discriminant's positive. Now if I start moving this graph around, there's still two solutions to when is that expression equal to 0. Still two solutions, and in all cases the discriminant is positive. But there is a case where these two solutions are getting closer together and the two solutions become equal. That's the equal solution case. There's really just one solution, and that's when the discriminant is 0. Now, this would be solving the equation x squared minus 4x plus 4 equals 0. There is only one solution, discriminant 0. And if I move this graph higher, there are no solutions to the equation. The discriminant is negative. So in the case x squared minus 4x plus 5 equals 0, we'll never find a value of x where the value of x squared minus 4x plus 5 is ever 0. There are no solutions. The discriminant is negative. Here's another case. Suppose we turn the graph upside down. It's concave downwards. Two solutions. Discriminant's positive. Two solutions. Discriminant's positive. One solution. Discriminant is 0. No solutions. The discriminant is negative. So let's now go back to the question. So for this equation to have equal roots, we now know the discriminant has to be 0. So we'll say that. For equal roots, the discriminant is 0. So that's our b squared minus 4ac is 0. Now we're looking at x squared plus k minus 5 lots of x plus 1 equals 0. And we're comparing it with ax squared plus bx plus c equals 0. So the discriminant will be b squared. Now we notice that b has value k minus 5. So it's k minus 5 squared, that's our b squared, minus 4 times a. A we can see is 1, times c. C we can see is also 1. So that's the discriminant. Let's try and simplify it. We've got k minus 5 times k minus 5 minus 4. Let's multiply that out. K squared, outside 2 is minus 5k, inside 2 is minus 5k, outside's, or the last, sorry, minus 5 times minus 5 is plus 25. Take away 4. So k squared minus 10k, 25 minus 4 is 21. So we're ending up with this being the number under the square root sign. And therefore, for equal roots, we require k squared minus 10k plus 21 equal 0. Now, this is a quadratic equation in its own right. Let's try and factorise it. So k times k gives us k squared. 3 times 7 would look promising since we have a 10 there. Let's look at the outside 2 giving us 7k, the inside 2 giving us 3k. How do we get a negative 10k from then? Minus 7k minus another 3k. So they both must be negative. We can check with the last product. Negative 3 times negative 7, the two last terms there, multiply to give us positive 21. So here we have something times something equals 0. One of these two factors must be 0. K minus 3 equals 0, or k minus 7 equals 0. In this case, k would be 3. In this case, k would be 7. So there we have the two possible values that k can take that gives this original equation equal roots. Now that's the question solved. In the exam you probably wouldn't have time to check these, but let's go ahead and try and substitute the value k equals 3 and see what happens. If k is 3, 3 minus 5 is negative 2. We get negative 2x plus 1 equals 0. That's what the equation becomes in the case of k equals 3. And sure enough, x minus 1 times x minus 1 gives you x squared minus 2x plus 1, and therefore x minus 1 equals 0 is the only solution. X equals 1. There is one value, two equal roots. And let's try k equals 7. X squared, putting k equals 7, we get 7 minus 5 equals 2. That's 2x plus 1 equals 0. That's what the equation reduces to for the value k equals 7. And again, well, this can be factored into x plus 1 times x plus 1 equals 0. Two equal factors. The only solution is x equals negative 1. There are two equal solutions. X equals negative 1. So we've double checked that for each of these values, that original equation has equal roots. That's Mr. Corsi signing out. Hope you enjoyed the video.